Hello everyone. So in this video, we'll be discussing matrices and matrix operations. So matrix basics must have studied in class 12th. So I won't go in depth for the basics, but I'll do the parts which are of more important or which are new to most of the students. Okay. So basically, starting with the basic definition of matrix. So it is a rectangular array of numbers which is considered as an entity. So rectangular array of numbers, right? So the numbers are plotted in a rectangular manner. Now what do we mean by m by n matrix or m cross n matrix? So it means this correspond to the number of rows in the matrix. The second n, so m cross n, the first m corresponds to the number of rows in the matrix and n corresponds to the number of columns in the matrix, and it can be also written as m cross n. So in this case, m cross n is also the order of the matrix. So a11, a12, a1n, these are the coefficients. So in this case, a11, a12, a1n, a21, a22, a2n, am1, am2, amn. In this case, there are m rows. And the number of columns is the second subscript denotes the number of columns. This would denote the total number of columns. So the total number of columns are n. So this is an m cross n matrix. Now we express the coefficients by aij, where the I part is the row. So if I am writing A32, this means we are talking about third row and corresponding to it second column. So in this case it would be A31, A32. So this is the third row, this is the third row, and the second column is this. So we are talking, this is the common thing. So we are talking about A32. I hope this was clear. Now try to find what would be the order of these two given matrices. Now look at matrix A. It has two rows, right? 1 and 2. So two rows and the number of columns are 1, 1, 2 and 3. So the order of A is 2 cross 3. Similarly, in case of B, there's 1 row, 2, 3, 4 rows and column is only 1. So 4 cross 1. Order of B is 4 cross 1. Now, what is a square matrix? When there are equal number of rows and columns in a matrix. Equal number of rows and columns in the matrix. So in this case, we have m equals to n and we get a square matrix. AII is the main diagonal along a square matrix. So suppose we are talking about 3 cross 3 matrix. So A11, A12, A13, A21, A22, A23, A31, A32, A33, and the main diagonal elements are AII, which would be A11 when I equals to 1, when I equals to 2 it would be A22, and when I equals to 3 it would be A33. So these are the main diagonals. Okay, now coming to some of the matrix operations. Two matrices are equal only when all the corresponding elements are equal in the given matrices. So if I give you this matrix, A equals to 1, 2, 3, 4 and B equals to 1 3 2 4. In this case, so for two matrices to be equal, first important thing is the dimension should be same. This is one row, two rows, two columns, two rows, two columns. So the dimensions are same. Now we need to check that whether the corresponding elements are also same. So this is same, but 3 is not equal to 2, and this is not equals to this, but 4 and 4 are equal. So the two conditions are, एक तो dimension same होना चाहिए, and second is हर मैट्रिक्स का corresponding element should be equal. अगर वो equal नहीं है तो मैट्रिक्स equal नहीं होगा. So basically Aij should be equals to Bij for all I from 1 to m and all j 1 to n. So basically same dimension and all their corresponding entries are equal. Okay, now since we have, so try to solve this example. I'm giving you 3 minutes. Try to solve this. Okay, first thing, that this dimension, this is 2 cross 2, this should be equal to 2 cross 2, and since they are equal, so the first element should be equals to this. So from, with the help of this, we get t equals to 3. Now this becomes t minus 1 becomes 2. So 2 should be equals to 2v. So 2 equals to 2v gives v equals to 1. So this is the second we have got. Now 2t. So since t was 3, so 2t should be equals to u plus 1. So basically 6 equals to u plus 1. So this gives us u equals to 5. Right? So this is 6 and u is 5. So this is 6, this would be 3, this would be 2. Then if u equals to 5, this would mean this term is equals to t plus w. So 5 equals to t was 3 plus w. So we have w equals to 2. It was fairly basic. So w is coming out to be 2 and t is 3. So this total sum is 5. Okay. Now, so these are the, so I won't be doing any example for this because this is very basic. Addition and multiplication by scalar. So these are the rules. So if A, B and C are matrices, then A plus B. So addition in matrices is only possible when dimension is same. Because suppose we have this matrix 1, 2, 1, 8. Suppose this is A and this is B. So we cannot add A plus B because the dimensions are different. In A it is 2 cross 2 or the order. For B it is 3 rows and 2 columns. Okay. So addition and subtraction is only possible when the dimensions are same. Okay, now moving forward. discussing about some of the rules. First is a plus b plus c is equals to a plus b plus c. These are the associative and the commutative rules. You must have studied this as well. Okay, then we have a plus b equals to b plus a plus the zero matrix equals to a plus minus of a would give you 0. If alpha and beta are scalars, that is they are any numbers, then alpha plus beta times a equals to alpha a plus beta a. Alpha multiplied by a plus b equals to alpha a plus alpha b. So you can just take these values 1, 3, 2, 6 and b is suppose minus 8, minus 3, 7, minus 4. Now you try to solve all these things. So c is suppose 1, 0, 0, 1. So just verify all these things. What would be minus a in this case? And suppose alpha is 2, beta is minus 1. Then try to just do one of this example. So this would be sufficient. Okay, now moving to 12.7 matrix multiplication. Now for matrix multiplication, the necessary condition is, so firstly we need to find the order of these matrices. So the order of A would be, since there are 2 rows and 3 columns, it would be 2 cross 3. And the order of B is 3 rows and 2 columns. So a matrix AB would be defined only when the number, okay, so for A it is 2 cross, okay, I'll just write it again. Okay, now A, which is 2 cross 3 and B, which is 3 cross 2. So AB would be defined only when the number of columns in A equals the number of rows in B. We're not concerned about the number of rows in A and the number of columns in B. So we want that the number of columns in A should be equals to number of rows in B. In this particular case only, we will have that A into B would be defined. Okay, you can just note this down. Now, how do we define it? Okay, so this is 2 cross 3 into 3 cross 2. So it would fetch you 2 cross 2. So it would give you a 2 cross 2 matrix. Now, so the first element would be C11, C12, C21, C22. How do we get C11? C11, multiplying this thing, the first row in A with the first column of B. So this gives us A11, B11 plus A12, B21 plus A13, B31. So this is C11. Now we need to find C12 as well. So C12 would be, okay, so C12 is multiplying this row with this particular column. So we have A11, B12 plus A12, B22 plus A13, B32. Similarly, C21 would be, this would be C21, the second row in A multiplying with first row, first column of B. So this would be A21 B11 plus A22 B21 plus A23 B31, and C22 would be, okay, so C2 would be second row of A multiplying with second column of B. So this would be A21 B12 plus A22 B22 plus A23 B32. Okay. Now this is a question which you should attempt. So try to find AB, what is AB equals to, and what is BA equals to. Okay, so solve this. I'm giving you 3 minutes to solve this. Okay, first find the order of the matrix and then proceed. Okay, firstly, the order of A is 1, 2, 2 cross 3, and the order of B is 3 cross 2. So order of A into B would be, this is same, so this would be 2 cross 2. Okay, so the first minus 2 4, 2 cross 2 multiplied with 2 4 1 minus 2 3 minus 5. So the first element would be, this is 3 cross 2. This row multiplied by first column. First row multiplied by first column. So this would be 8 into 2 plus 3 into 4 plus minus 2 into 1. I'll write it below. Okay, so the first column, so the first element would be of AB would be the first row multiplied by the first column. This would be 8 into 2 plus 3 into 4 plus minus 2 into 1. Then the second, so this is C11, so C12 would be the first row multiplied with the second column. So this becomes 8 into minus 2 plus 3 into 3 plus minus 2 into minus 5. And C21 would be second row multiplied by the first column, which is 1 into 2 plus 0 into 4 plus 4 into 1. And then C22, the final element, would be the second row multiplied with second column. So this is 1 into minus 2 plus 0 into 3 plus 4 into minus 5. So this would be 16 plus 12, 28 minus 2, 26. Minus 16 plus 9, So this is minus 16 plus 9 plus 10. So 19 minus 16 is 3. And 2 plus 0 plus 4, 6. This is minus 2, minus 20, minus 22. So this is A into B. So you can find, okay, so first tell me what would be the dimension of B into A. So this is the number of columns of the first matrix should be equals to number of rows of the second. So the dimension of B into A would be 3 cross 3. So you can find what the value would be. Okay, this is more of a homework for you to solve this. Okay, now how do we represent system of equations in matrix form? So suppose if we have this system of equation, 3x1 plus 4x2 equals to 5, 7x1 minus 2x2 equals to 5. So these are two equations and two variables. So the coefficients are 3, 4, 7 and minus 2. So a11 is 3, a12 is 4, a21 7 and a22 minus 2. X equals x1 and x2. B is the right hand side that we have discussed in the Leontief model as well. We discussed in the Leontief model what B was. Now just recall what was final demand, what was input demand, and what was gross output. And if you are not able to recall it, just revise the Leontief model again. And B was 5 and 2. So this can be written as AX into B. So this becomes 3 times 3, 4, 7 minus 2 into x1, x2 equals to 5, 2. Okay, so we have done with 12.7, and in the next video I'll try to complete chapter 12 in whole. So we'll start with chapter 13 soon, but in the next video I'll complete chapter 12 first. Okay, thank you.